Thank you, and thanks for the invitation. You are discussing subjects that really interest me in my own research, but that's not exactly what I'm invited to talk about. I'm a biodiversity researcher that has been working on biodiversity ecosystem services in agricultural landscapes for many years, often with climate aspects. But I've also been then a member of the Climate Policy Council, and I'm going to talk about that work today because that was what I was invited for. So I will give a very, very brief introduction to what the Climate Policy Council is, and then what we specially did about agriculture this year. So in Sweden, we have a system to handle climate issues decided by the parliament, where we have specific climate goals, Swedish goals that are different from, but not that different from the EU goals that also bind us. We have a climate law which deals with how the government needs to handle this, including reporting what they are doing. And then we have the Climate Policy Council, which is part of this decided framework, who has the obligation to sort of overview this process from a scientific perspective. And the Climate Policy Council consists of a number of researchers, including Philip, who I see on the program is going to talk later, but also a fantastic office led by Ola Alterå, who help with the mass work that is needed to be done by compilation, all the things that the government has been doing the last year. I would here especially like to stress Rasmus Einarsson, who was a temporary part of the office during the production of this report that I'm going to present now, because of his knowledge about agriculture, and we worked a lot together on what I'm going to present today. But the Climate Policy Council should then evaluate how the government's overall policy aligns with the climate goals that are then set by Parliament and the government. And we are not policy prescriptive. We evaluate if the current policies are actually living up to the ambition of the climate goals. So what has happened the last year, what policies have been decided, and are we likely to meet the climate goals in the future? We also discussed then what measures are needed in the future, but not so that we are prescriptive, but stating that there is, for example, a gap, and then that gap might be covered by some actions. So we always have balanced, I'm not part of the formula anymore, balance between stating that some actions are good to take, and that we have a sort of a palette of different actions that could be taken. And we have been criticized from both sides of not being sufficiently policy prescriptive and being too policy prescriptive. So I think we have striken a balance between those two. We should also contribute to the discussion in society, which is, part of what I'm doing today. And I'm not going to talk much about the general assessment of the government's policy that we did, except to state the overall assessment, which was that Sweden's goals and the EU commitments for 2030 will not be achieved with current policies, and that some efforts in 2024 were in the right direction, but they do not offset previous decisions that have increased emissions. And those were mostly about the obligatory mix with biofuels that was abolished partly by the government. What I'm going to talk about today is the contribution of Swedish agriculture to the climate transition. We had it as a special theme, and I will show you why we had that. It's not the biggest contributor to climate change, but it's just, we thought, a particularly problematic area, together with, of course, forestry, which will be likely treated in the future. The focus of the Climate Policy Council by regulation is territorial emissions. So it's the emission caused by agriculture in Sweden, by the sector agriculture. And it's important to realize that this is not the total consequences of agriculture. We have, for example, and this is illustrated in this figure, that we have the emissions by the Swedish agriculture in the middle. We have additional emissions caused by inputs, and we have also additions that are caused by downstream consequences of Swedish agriculture in the food industry and the retail industry, by consumers, including, for example, transportation. We also have then positive emissions, which you are partly discussing today, I guess, where agriculture can contribute to the emissions in other sectors by, for example, providing biofuels. But here I'm focusing, for formal reasons, on the contribution by Swedish agriculture as a territorial emission. And here is the official statistics of the total territorial greenhouse gas emissions in Sweden to 1990 to 2023. And as you can see, there are significant reduction in how much greenhouse gases Sweden are emitting territorially. The important thing to note here is that it's going down in most sectors, but not really in agriculture. And this has a consequence, because on the road to net zero, the transition to the final goal of reducing the emissions to nearly nothing, agriculture will have a progressively increasing share of the emissions if this is not solved. And that means that there is a need to really focus on agriculture now to be able to have positive consequences for the climate down the road, because everything takes time to implement, and we don't have the kind of automatic system that we have for example, the general emissions that are in part of the EU trading system. If we look at what actually constitutes agriculture's emissions, you can first see that it's a little bit smaller than other sectors. It's a little bit smaller than transport and industry. But if we add all the different contributions by agriculture that are part of Sweden's obligations, it's actually quite big. It's on the same scale as transport and industry. And it consists of both emissions from the sector agriculture and agriculture's share of LULUCF, for example, emissions from organic soils that are used by agriculture. There's a small share also of agriculture's fossil fuels, but it's not the major part of what is going on. And if we look at where the emissions comes from, it's clear from the emission in the directly from agriculture that it's mostly enteric fermentation, and you can also then wrong spelling here. It's also manure storage that contributes to this, and then we also have a relatively big emission by cultivated land. We also have the LULUCF part, which is mostly about arable land with a minor contribution from pastures. So here we can consider what we actually need to focus on if we are going to change the emissions from agriculture. It also then shows the difficulty of working with agriculture because some of these emissions, they are biological emissions, so they are sort of technically much more difficult to work with than emissions from other sectors, where you can find more easy technical solutions. You don't really have a technical solution to reduce the methane production of a cow to zero. So what we wanted to do here was to consider ways for agriculture to reduce the emissions, and then we went through what actually are the preconditions that make this a difficult field. One is synergies and conflicts from any transition, which I will go through in a second. It's also, as I said, it's biogenic emissions, so they're hard to tackle. In addition to that, we have a generally low profitability in agriculture, which means that it can be hard to expect a big voluntary part of reduction emissions. So it's important that any policy actually consider the consequences for profitability. We also have a very large number of actors, so any process that is involving actors is much more complicated than in sectors that have relatively few actors. The synergies and conflicts that we considered was, for example, food supply, where we might have both synergies. For example, more efficient food production normally reduces the emissions, and conflicts, which is a lot about the total volume of produce. I will come back to that a bit later. But in our work here, we took as a point of departure the Swedish food strategy, which argues for an increased Swedish production of food. We also have the biodiversity conflict, which is also a bit difficult. We have the grazing by cattle, which is in parts not fully important for biodiversity, especially the grazing of semi-natural land, but also then a large emitter of greenhouse gases. We have potential synergies, which is mostly about carbon sequestration. What we did in our work was to assume that we should preserve semi-natural grasslands as currently. As a side note, I can note that the nature restoration law that now is implemented or going to be implemented in Sweden requires actually an expansion of those grasslands. We considered the climate mitigation synergies with carbon sequestration. We also, in some of our work, considered public health benefits, where we did scenarios related to recommendations for diet changes in the Nordic countries. And we considered the economy of farmers to be a very constraining condition for any policies to be implemented. So what we totally did in our work was to look at sort of technical and structural solutions to answer the question, what potential exists to reduce greenhouse gas emission in Swedish agriculture? And this is about creating scenarios. So that is mostly what I'm going to talk about here. But we also had analysis of the barriers. So what obstacle needs to be overcome to implement these potential changes, and what governance is needed to do that. And I guess that Philip is partly coming into that in his talk. So what we here did was mostly for the scenarios an analysis of potentials. And I think it's important to realize what we actually did. We did not consider how we should achieve these different scenarios, or which are the best scenarios. We did this because it's important to realize if there is a potential to get down the agricultural emissions, because if we can't, we need to overcompensate this in other sectors to get a total net zero for Sweden. So this is crucial both for agriculture and for other sectors in Sweden. And what we then focused on was three things. One is how production is carried out. that is, we call it climate technology, that is different measures that you can introduce, technological solutions to reduce the emissions from agriculture. We also looked at what and how much is produced. So that is structural changes to agriculture. How much production of meat do we have, for example? And we looked at this with and without dietary changes. And I will show later why what and dietary changes are partly disconnected in our scenarios. So the basic assumptions we had here was increased food production and maintained area of agricultural land. And we wanted to then show what can be done. For that, we constructed a system, a model, which was largely the result of Rasmus' work with inputs from me, but I want to credit him really for this. The model then makes sure that whatever we do match up, so that in principle, if we decide to reduce the amount of production of meat or increase it, there are parallel changes in, for example, fodder production, and that the total amount of arable land in Sweden is kept relatively constant. So we have these consequential changes of the different components of the scenarios. That is essentially what the system model is. So we formulated then scenarios of possible futures until 2045, and focused then on the net emissions, on how what production is done and what is done, and how much, including assessing the contribution to dietary scenarios. So we quantified effects on territorial emissions, agricultural production and trade, and looked at the consequences for also Sweden's footprint outside Sweden. Of course, in a group like this, we can't have a large research project, so we relied here on assessment that we got in from, for example, RISE, SWECO, and otherwise mostly official statistics. So a lot can be said about the details of this model. You can question the individual measures that we have used and so on, but I don't think it changes anything in the big picture. So here, how is the efficiency? It's basically reduced emissions by unit of food that is optimized by an array of different methods that we identified, including management, animal breeding, plant breeding, and new technology, sort of educated guesses of what this will result in. We did that both for the business as usual scenario. We assume that agriculture is going to be more efficient in the future, and then we analyze scenarios where we put in extra policy supported technological changes in agriculture. The what and how much it was structural issues then. We basically had scenarios where we looked at the production of animal products and the consequential changes of crops of various types. I will go into the scenarios in more detail in a minute. The measures we looked at was general increased productivity, efficient use of N, but those are more technical solutions like nitrification inhibitors, the use of methane-reducing feed additives, and so on. So it's a combination of sort of, they're not that novel, but novel technologies and general improvement in agriculture. It also included things like rewetting of organic soils, which is a major contributor to climate change. And also use of more cover crops. From this, we developed 6 scenarios by crossing 3 ways to produce and 1 dietary scenarios with and or without a lot of technological improvements. So the basic scenario was what we call here for upscaling, which is an increase in animal products with 20% in Sweden. This is because we respected the Swedish food policy, which requires more production in Sweden, and import of meat is a major part of the sort of unbalance in the trade for agricultural products. So we assume that they should increase. We had then a scenario of a change in the production from then ruminants to other animals like pigs, chickens, egg production, to reduce the methane production. We also had a scenario where we reduced the consumption of meat in Sweden. We assumed a reduction of 30%, and that reduction is what is recommended by the Nordic dietary recommendations. And then we had this with or without climate technology, where we was mostly more efficient use, the use of methane reducing food additives, nitrification blockers, and more mellangrödor, intermediate crops. So that's basically our scenarios, and you can look up the exact details of the quantities we used. We try to use realistic quantities in these scenarios. Looking at that in our system model, we can compare the consequences for Swedish emissions with the goal scenarios that are set up by the Swedish Environmental Protection Agency, that is the needed contribution from agriculture if Sweden is going to reach the climate goals. And what you can see here is that the currently we have a long way to go. In the scenario with more food production in Sweden, we get even worse. If we have climate technology, it helps, but not sufficiently. If we change the production of meat to less methane production animals, we can't also not reach the goals. Only if we combine these measures, for example, having a more vegetarian diet and technology, we get really big reductions. So combining these different measures is a way where we actually can achieve quite significant changes in the emissions. And you can see in this figure that if we don't do anything up to the left, we assume that we are getting more releases. But if we go down to the lower right, we have emission reduction of 36%. And also in the middle right scenario, it's minus 24%. It shows that there is a large potential to actually change the contribution of agriculture in Sweden to climate change, but it requires both technological and structural changes to be really efficient. Now, someone might wonder here, why is not a changed diet contributing more? This is based on an assumption in the model. We are looking here at the territorial emissions. We can also look at what is the consequences of our scenarios for the imprint in other countries. And then we can see that the business as usual scenario results in an increased imprint in other countries. It's a reduction of the imprint in all our other scenarios. And that is because we increased the food production in Sweden. But the scenarios with dietary changes reduces in quite dramatic reductions of the imprint of Sweden's food consumption in other countries. And we have not calculated the climate impact of this. So this is an added benefit of changes in the diet that is not part of our calculations. So the global climate footprint of Sweden's agriculture will be dramatically reduced if we also include changes in the diet on top of the other changes that we proposed. There's been some debate about this. There was some extreme articles out there where we wanted to take away all meat from all people and so on. I would like to note here that, first of all, we don't provide recommendations here. This is just scenarios to see what different policy options could contribute to it. And also that the scenario which used was the Nordic recommendation for diet, not a very extreme scenario, I would say. So to conclude this, we show, minus sign missing here, we show that in different scenarios, the reductions goes from being more greenhouse gases, 3%, to actually minus 26%. So there is a big potential, but it consists of a lot of different measures that need to be reduced. And the most likely scenarios to reduce in big reductions require a combination of technical and structural measures. I haven't shown the data for this here, but several of these measures are actually cost effective if you look at how much reductions in carbon dioxide equivalents cost in other sectors. Many of these measures have also positive potential impacts on other sectors. And I would like to note here that we made the assumption that there should be no negative impact on the grazing of semi-natural grasslands, but that is partly another issue than here. It's quite a low proportion of animals that actually graze on these grasslands. It also shows that we can have a increased, a decreased climate impact, and at the same time increase the self-sufficiency in Swedish food production. I note here self-sufficiency rather than the food security, because food security then is about a lot of other issues that we actually didn't really cover in our compilations here. But I also would like to stress here that what we didn't include, and what is important if you don't only consider the specific climate goals, which is our task, is that there is a large potential to reduce the impact of Swedish consumption in other countries, which I think is important to realize. So from that, we proposed a roadmap for the future. We suggested that there is a need to develop a common vision and strategy in close collaboration with relevant stakeholders. And we actually looked quite a lot on Denmark for this. We also stated that the government has the obligation to show how the Swedish food strategy, with a demand of increased production, should be achieved within the framework of the climate goals. And to just take up some of the things we otherwise recommended was that there should be a design for risk-sharing systems for climate investments in the agricultural sector, because of its low profitability, so that farmers dare to take risk of investing in new technology. We also thought that for some of these measures that are cost efficient in a societal perspective, but not in a farmer perspective, there needs to be enhanced economic support for farmers. We also had a more daring recommendation that in the absence of a climate policy instrument in the EU for this sector, that Sweden should consider starting to price methane and nitrous oxide emissions in agriculture, but then also, of course, have some sort of compensation for farmers to achieve economic neutrality at a larger scale. Some other things were more tangential for the discussion here, but we argued also that the government could, if they wanted, stimulate an increased demand for healthy foods with low climate emissions. So to end this, our overarching conclusion was that the existing policy in Sweden doesn't encompass all the measures that can reduce emissions at low cost, and it's largely conserving the current structure. That last part of the sentence really points to the EU regulations. But also that there's a lack of a clear vision for agriculture's contribution to the climate transition, and that it's really urgent to create such a vision to have sort of a clear goal of what you want to achieve in the future. And with that, thank you.